Alrighty, so we're going to look at slope fields. So slope fields were not a thing that I learned when I took calculus way back in the day, not in the old textbooks. It wasn't tested on the AP exam until the early 2000s, so I'm not sure exactly when somebody kind of decided these were a thing. They are helpful, though. It's not like it's ridiculous or anything. But so a slope field is a graphical representation of the solutions of a first-order differential equation. So that sounds all fancy. A differential equation is anything that has dy dx in it when you take the derivative. So we've been dealing with differential equations all year. Okay, we just didn't necessarily call them that. They provide us visual clues, bless you, to the behavior of the solutions of first order. And first order means it's the first derivative, not the second derivative or whatever. So the differential equation gives the slope at any point. So remember, when you take the derivative, you were finding slope at a point. It's an instantaneous thing. Therefore, we can use that information to draw a small piece of the linearization at that point. It's the small piece of the slope. That's all we're doing. All right, so let's just get into this and it'll make more sense. So we have this differential equation. That means we took the derivative. Here it is. So this is the equation that gives you the slope of the tangent line at any given point. All right, and we're going to go through and we're going to find these points, and then we are going to sketch them down here. Okay, we're sketching little tiny pieces of the tangent lines. So at -1, -1, your slope is 0. So when I go to -1, -1 down here, when I go to -1, -1, the slope is 0. So I'm just going to draw a tiny little piece of a 0 slope. Okay. All right. So then I'm going to go back up here and using this equation right here, and the point 0, -1, we're going to do dy dx, and that's going to be equal to the x minus the y, which is going to give me a +1. Okay? So then I'm going to go to 0, -1, and when you do this, nobody's getting out a ruler and a protractor and trying to make sure your angle is exact. But there are times where it needs to be more steep than others, and we'll kind of talk about that when we get there. But if I'm here and I have a slope of 1, if I was going to draw an entire line, I would go up 1 over 1 to here, right? I'm not going to draw that whole thing, but if I kind of visualize that, I want to get that slope in there like that. Okay, so you kind of aim for that other point and just draw yourself a little tiny segment, okay? That makes sense? All right, so then I'm going to go back up here. And then we're going to do dy dx. That's equal to 1 minus a -1, which is 2. So then when I go to the point 1, -1, my slope is 2. All right, so when I go to 1, -1, my slope is 2, which is steeper than this one, right? So if this would be 1, then I'd go up 2 over 1, so I'm kind of aiming for that. So you want to make it look, what's that? My jacket did that. Let me redo both of those. Goodness gracious. You definitely want to make it look steeper than the other one, okay? We good with that? All right, so we're going to go back up here. dy dx equals -1 minus 0, which is -1. So when I go to -1, 0, if my slope is -1, it will look something like that, right? And these can be kind of time consuming. They're not difficult. They just take time. And then dy dx is 0 minus 0, which is 0. So at 0, 0, I have a 0 slope again. Okay. Then dy dx equals 1 minus 0, which is 1. So at 1, 0, I have a slope of 1, which should be about the same as that one, right? Because that one was a 1. then dy dx equals -1 minus 1. So that's -2. So at -1, 1, -2, I'm aiming for this one and that one, right? So it's it should be steeper than the one that was a -1. Then here, dy dx is 0 minus 1, -1. So at 0, 1, I'm at -1. And then dy dx, 1 minus 1, which is 0. Okay, so this is a slope field. If you were asked to do one, this may be one that they're not going to ask you to really sketch or draw anything, but possibly a slope field. All right, and you'll either have 9 points or 12 points. Not difficult, hopefully, but might be a little bit time consuming. The idea here is we start to see a pattern, which when you only have 9 points, you don't really see it. And that's fine. Well, right now, if you can't really see what a pattern is, we'll talk about the patterns and stuff in just a minute. But as long as you can actually sketch it. Can we sketch that? Does that make sense? Okay. So then I want you to flip this over. And I'm going to give you a minute. I want you to sketch this one, number 1. Same idea for each ordered pair. This time the ordered pairs aren't written out, but for each ordered pair, and I bet you'll see that you'll find a pattern pretty quickly, and it won't take you even as long as the last one, even though this has more points. Okay. You don't have to. No, you don't have to write your workout. I did over there just so we understood where it was coming from. But no, you don't have to write your workout unless you want to. What is that? Oh. Yeah, so it's just the x. So whatever the x value is, add 1, and that's the slope. Uh-huh. You're not done. You got to do them all, but then you'll find that it'll go kind of quickly once you get the next one. Yeah, just do number 1 for right now. Yeah, actually, if you're done with number 1, you can move on to number 2. We'll get there too. Okay, so I think that some of y'all kind of figured out what was going on here, right? So if it only depends on x, so at the point 0, 0, x is 0. At the point 0, 1, x is 0. At the point 0, 2, x is 0. So they are the same for every y value. Oops. And then steeper. And then even steeper than that. All right. Those are all 0. Something like that? All right. So if you were looking for a pattern here and thinking about the fact that these are the slopes of the tiny little tangent lines that you could draw along your figure, what kind of figure do you think this would be the slopes of? Kind of looks like a parabola, huh? So if you were asked to draw, now I know this whole thing doesn't look like a parabola, okay? I gave you that. But you could be given a slope field, and we'll talk about what the whole field means when all we're looking at is a parabola here in just a second. But you could be given a point, let's say we were given the point negative 1, 0. Okay, so let's say we were given this point. And then you are told to sketch in the figure that this will be the slope field of. You just kind of follow along the lines of what you have. If we do that, then we can get this here and this here. See how that works in there? Following the slopes like that? Okay? That's kind of what's happening there, because there's an infinite amount of them in there. And now let's talk about why that happens, because we're going to get into actually solving these differential equations, which in a way we've kind of already done. So if I have this equation here, I'm going to take this dx and I'm going to multiply both sides by dx. So I'm going to get dy equals x plus 1 times dx. Okay? Now if you think about, we took the derivative of something to get this. Wouldn't you take the derivative of a quadratic to get a linear? Right? Okay. So then if I integrate this now, integrate both sides. When I integrate dy, I just get y. And when I integrate x plus 1, when I integrate x, what do I get? X squared over 2 plus x plus c. Okay? That c right there is why we have a whole field of stuff. Because what does that c graphically do to my function? What's the transformation? Shifts it up and down, right? So they gave me this point, but can't you see if I could shift it up or down and it still fits in that slope field, right? Because there are an infinite amount of functions that share this derivative because of this constant right here. Okay, so that's why you have just that part there. Okay, we good? Yes, sort of? All right, so notice here, it only depended on x. So all the y value things were the same. So when we look at number 2, this one only depends on y. So when y is 0, the slope is 0 all the way along. When y is 1, what is the slope? 2, and all those would be the same, right? And so forth and so on. It's really when you have x and y that it takes you a little longer to write them all out, okay? Are we all okay with sketching a slope field? There's many, many more examples, but I don't think we need to do all of them, okay? We okay on those? All right, beautiful. Then we are going to jump to, the next piece of paper that is not in your hands. Oh, goodness. Okay. One, two, three, four. 1, 2. Let me grab one more. There we go. All right, let's go down to bottom here. See this one where it says solution curves? All right, y'all pay attention. Hey, psst. This is the side you're looking at where it starts with number 4, but we're going to skip those because we could sketch all day. But all right, so your solution curves. If we sketch a curve connecting the slopes of a slope field, we get a particular solution curve, meaning a specific one, not that it could just be anything there. By doing this, we can often see the solution to a differential equation without solving algebraically. So what do you think this first one looks like? What do you think we could sketch in there? Look like a quadratic? And then they even give me this. If I take a quadratic, would this look like a derivative I could get? What's the derivative of x squared? 2x, right? And so I'd go with quadratic. So remember, you just kind of follow along the curves like this, just making sure that you go through whatever specific point they give you. Like here, they didn't give us a specific point, so we don't know where we're going through. But all right, so what does this one look like it would be? Cubic, right? Plus, we end up with a quadratic. Don't you get a cubic or a quadratic when you take the derivative of a cubic, right? So I could start here and kind of go through something like that. But if you were asked to sketch one in, then you were going to be given a it would say like you have to go through 0.01 or you have to go through 0.23 or whatever. And we'll look at those too. Okay, everybody okay with those? All right. So let's go through another one, or let's go through these together and this one, and then I'll let you go on the next one. We're going to do some matching. And so this is not multiple choice, it's matching. But I just want you to look at these different graphs and not necessarily try and figure out what you would sketch, because that's not really what it's asking you, and sometimes you may not be able to figure it out easily, or even if you can, you wouldn't know what the equation was, and that's fine. But do you notice any other kind of patterns happening here? Like, what do you notice about A? All the horizontals are the same, right? So if I picked a horizontal line, any of them, I see just, they're exactly the same all the way across, right? So that means that dy dx depends only on y, because those are y equals lines. Okay, like a horizontal line would be a y equals line. When you look at B, do you see these vertical ones? You could choose any of them, right? So that means that dy dx depends only on x. What do you think about C? So if I do horizontally, is it going to be the same? No. Vertically, is it? Yes. It looks very different than B, right? But you can choose any of these, and here dy dx depends only on x. Now look at D. If you pick any vertical, are they all the same? No, right? Are the horizontal, are they all the same? No. Okay, because remember, we have to be able to pick any of them. And vertically, they're not all the same. Horizontally, they're not all the same. So that means here that dy dx depends on x and y. So being able to recognize those things are going to help us with these answer choices. So if you look at number 1, this only depends on x, 2 is x and y, 3 is only y, 4 is only x. So this is the only one that depends on x and y, right? Which means my answer, that's D, it has to go with 2. There's only one that depends only on y, that's A, so that has to go with number 3. So then we have B and C for 1 and 4. And if you take the antiderivative of x, what do you get? Or if you integrate x, what kind of function do you get? Quadratic, okay. So here, y would equal some sort of quadratic, right? X squared or whatever. And then if you take the, what I should say, it's x squared over 2 plus c. I shouldn't just say whatever. If I take the antiderivative of sine, what do I get? Negative cosine, okay? And so these are the things that you should be seeing in there. Which one looks like it's x squared over 2? B. And then do you see the negative cosine here? You see how you can see a cosine curve coming in here like that, right? So this is C, this is B. And that's how you would match those things up. Okay? We okay with all that? All right, so now I want you to look at the next set. I'll give you a few minutes to talk through these and match these up. Get off your phone and do the question. You finished? He is trying to work. You get your phone out of his face. All right, do we want to talk about them? Okay, so I saw some things written out. Some of you wrote out like lots of words and stuff, which is totally fine. But if I look at this here, I don't have either one has a pattern, so this would be X and Y, right? This one here only depends on X. This one here only depends on Y. And then this one here kind of looks like maybe it depends on X, right? But you have to be able to do that at any point, and you can't. And so this one's going to be X and Y also. Okay, so that far, are we good that far? Okay, which means I can look down here. There's only one that depends only on X, so this has to be B. There's only one that depends only on Y. This has to be C. Okay? Then we have to be able to figure out which one of these is going to work for us. So we can pick a point, right? And we can make this kind of easy on ourselves. Let's pick 0, 0. Okay? So if 0, 0, that means when X is 0, the whole thing is 0. That's true here. And all of these X values are 0, right? And so when if we're at 0, 1, 0 plus 1 would not give me 0, and I still have a slope of 0. So I'm pretty sure this is not D. And if I looked over here, you can see when it's 0, 1, 2, 3, and you're getting steeper and steeper. So this one has to be A, and this one has to be D. Okay? Everybody okay with that? Anybody think about it a different way? No? Okay. Any questions at all? All right, good deal. All right. Next one says, the slope field from a certain differential equation is shown above. It's really shown below. Which of the following could be a specific solution to that differential equation? All right, so although they do not have in here a point for me to start with, I can start anywhere just to kind of sketch something for myself, right? And so if I started here and I can just kind of sketch this in, something like that, well, then we should know what these things look like, right? When you sketch x squared, it looks like this. When you sketch e to the x, what does that look like? Like that. It's exponential, right? E to the negative x, that's a reflection in y. It looks like that. Natural log looks like that. So what's your answer? D. Okay? That's pretty easy. All right. One more page with just 2 questions. Oh my God, get over yourselves. I know. We got 15 minutes left. Yeah, 15.
You were nuts.
Oh my, so dramatic. Okay, so here's some examples from an actual AP exam. Here's one thing that you always want to pay attention to, no matter what, is the scale on the x and y axis. Because these aren't counting by ones. This is at 3, so that means, a lot of other stuff going on there. So it says, shown above is a slope field for this differential equation. If y equals g of x is the solution, so y equals g of x is the solution to the differential equation, with this being the initial condition, then find the limit. Okay? So, what? Yeah. Okay, so y equals g of x. It is the solution, which means that's what is graphed up there. And it gives me this initial condition, this -2, -1. So -2, -1 is my initial condition. Now, this is counting by whatevers, and I can count them down if I want to, but I can also just kind of estimate on here. -2 would be probably right about there, right? -1 maybe right about there. So that means I'm starting kind of here. That's my initial condition, okay? This here on the y-axis, the x-axis that you can't really see, it's not like they just didn't put the slopes on there. It's that the slopes are all 0, and that's why it looks like you can't see anything, okay? So that means that here, it should look something like this. Okay. Does all that make sense with the information that you were given? This is one of those where they gave you an initial point. And if you were expected to, like, you need to sketch this for yourself. If this is one where the sketch was your answer, they'd actually put the point on there for you, or it'd be easier to graph the point exactly. Okay, but it's fine to kind of guesstimate here. So the limit of g of x as x approaches infinity is what? 0. As x goes to infinity, y is approaching 0. My answer is C. So it looks all scary and intimidating, and it's really not that bad. You can't get real crazy with the slope fields, okay? They should be fairly simple questions when you have to do that. Now, notice this. I could have also graphed something that looks like this, right? And then my limit is something else. But I have this initial condition, and if I have that initial condition, then that's not what's happening there, okay? Because if this is an asymptote, even if I cross the asymptote, I'm still going to come back down on top of it either way. Okay? What questions we got? You good? All right, look at the next one. See if you can, I'm going to give you a minute, give you a few minutes to talk, think about this one. Eeny, meeny, miny, mo. All right, let's talk through. Let's see. Is there anything you can eliminate from the very beginning? Any of the answer choices? E, why? Good, because this has to depend on x and y, right? E only depends on y. When you have that many to choose from, which we didn't when we were matching, right? And so, yes, you can look at certain points and stuff, but let me show you something that's something else you can do here, is you can find your zero slopes. My zero slopes occur when x equals 0 and when y equals what? 1, because this is 3, right? And so we basically have to count by 2s there, like by 0.5s. So that's at y equals 1. Right? Does that make sense? So that's when I'm going to get 0 as my answer when x is 0 and when y is 1. So then if I look at my answer choices down here, I'm going to set them equal to 0 and factor. If I factor out that x, that leaves me with y minus 1. Okay, so when x is 0, I get 0, yes? When y is 1, do I also get 0? What's 1 minus 1? 0, and 0 times anything's going to be 0. So A is still, I can't eliminate that one yet. We do the same thing here. 0 equals x times y plus 1. Well, when x is 0, y is what? I'm sorry, when x is 0, the slope is 0, right? When y is 1, the slope is not going to be 0, is it? Nope, so we don't like B. All right, so here, can't really factor that out necessarily, but if I said 0 equals y minus x squared, that would mean that y equals x squared. So when x is 0, then that makes y, I mean, that's not really going to work out there, is it, right? If I took the square root of, if I took the square root, not taking the square root, if I took the integral of this, I'd get a cubic. Do you see a cubic in there? No. Okay. So we're going to go with a no on that one. And then y minus 1, is that going to be, would that give me 0? 1 minus 1 gives me 0 for the whole thing? Yes? If x is 0, does it give me 0 for the whole thing? Yes. So then these two are still both in the running, right? So now if you look at what's happening, so we have to look at one more thing, or we can choose some points. But if you just look down in this, I know in the third quadrant, everything is negative, negative, right? And negative, negative, look at all these slopes. What do all of these slopes have in common? They're all positive, right? So if I put a negative number in here and a negative number in here, I'm going to get a negative times a negative, right? Which will give me a positive slope, so I think I still like A. If I put a negative number in here, this will be negative, but this, because I square it, it's always positive. So these would actually give me a negative slope in the third quadrant. That's what makes my answer A. Okay? A lot of reasoning skills there. Right? See it out. Dorks. All right. We good? What questions you got? All right.